In the 1940s, during the World War II, the U.S. successfully tested its first atomic bomb in Nevada. 8 days after the test, President Truman ordered to drop 2 atomic bombs in the sites of Hiroshima and Nagasaki in Japan. Seeing the devastation caused by these bombs, and seeing the shift in power at the global scale, the Soviets started working on their own nuclear weapons project, which led to the 2 Allied superpowers during World War II into a new type of war, the Cold War, which resulted in rapid development in the nuclear technology on both sides in the field of weapons, energy, and nuclear propulsion. The nuclear arms race. During the Cold War, research began in developing a new type of propulsion technology using nuclear energy as sourced by the United States and the Soviet Union. The research was to be used to make nuclear-powered aircrafts, as they would presumably allow a country to keep nuclear bombers in the air for extremely long periods of time. It was a useful tactic for nuclear deterrence. As the advancement in nuclear research were happening, many breakthroughs and uses were discovered in emission-free energy and propulsion, one of which is the dawn of nuclear marine propulsion. In the 1940s, under the direction of U.S. Navy Captain Hyman G. Rickover, the design, development, and production of nuclear marine propulsion plants started in the United States. Later in 1955, the first nuclear submarine, USS Nautilus, was to sea, which completed its first polar voyage in 1958. Today, most of the U.S. Navy's aircraft carriers and submarines are nuclear-powered. The Big Bang. During the arms race, the U.S. Air Force, NASA, and DARPA started working on a nuclear-powered space rocket called Project Orion in the 1950s. In this project, the idea was to use a series of small nuclear explosions to propel the spacecraft into space, which is known as the nuclear pulse drive. They would detonate a bomb from it behind the ship. After then, the shock wave would radiate it into the pusher plate, giving the entire spacecraft a strong push. The pusher plate would be supported by 2 massive 2-stage shock absorbers, which would smooth the acceleration transmission. This would be repeated several times to the rest of the spacecraft, using a variety of nukes from 140 kilos to as much as a ton, and they would simulate a depth charge. Up to 300,000 warheads are employed, firing one every 1.1 seconds at an acceleration of 10 days, which is around 3.3% the speed of light, and take around 133 years to reach the nearest star system, Alpha Centauri. This Orion spacecraft was the ideal solution to the problem of visiting Mars, Saturn's moons, and, eventually, distant stars. By the 1970s, there were plans created for fictitious manned voyages to Saturn in the Orion power chip, which would be constructed by shipfitters in Virginia along the East Coast due to their experience with heavy-duty steel building. Compared to the lightweight aerospace methods utilized for aircraft, that would be preferable. They imagined launching a floating city in orbit by the late 1960s, which seemed tremendously feasible to them. Yet, the ultimate presidential nod of approval was what decided its fate. Early in the 1960s, the team made it as far as presenting a scale model of the Orion battleship to then-President Kennedy, but this extremely detailed model, which was packed with weaponry and nuclear weapons, ultimately turned the president off and caused him to immediately stop the program. It turns out that deploying a warship into space will not be aligned with the Federation's and the peace's philosophies. It would unquestionably escalate the Cold War and not at all put the Soviets at ease. Likewise, Scott Lowther of AerospaceProjectsReview.com noted, on the other hand, had the U.S. actually fielded a full-sized Orion battleship, it would not only have undoubtedly achieved space domination but also taken the first significant steps towards a true interplanetary transport and commerce system as opposed to inching to Mars in a tiny aluminum bubble. The U.S. would have possessed ships that could transport hundreds of passengers as well as thousands of tons of payload. Later in the early 2000s, NASA restarted its nuclear propulsion project. Now, instead of using a nuclear pulse drive, they are using a new nuclear propulsion method known as nuclear thermal propulsion. A nuclear thermal rocket, NTR, is a type of thermal rocket where the heat from a nuclear reaction, often nuclear fission, replaces the chemical energy of the propellants in a chemical rocket. In an NTR, a working fluid, which is usually liquid hydrogen, is heated to a high temperature in a nuclear reactor and then expands through a rocket nozzle to create thrust. The external nuclear heat source theoretically allows a higher effective exhaust velocity and is expected to double or triple payload capacity compared to chemical propellants that store energy internally. Race to Mars and beyond. As the research funding was drying up, due to China's rise in space technology and threat of dominance in the space exploration, and its announcement of its Moon mission to build a base on the Moon to compete with the United States Moon program, NASA reignited its Artemis space program, in which NASA is planning a manned Moon mission to explore the Moon and test out its new technology for getting up and ready for a manned Moon mission, which also revitalizes interest in nuclear propulsion technology. So, in 2019, the U.S. Congress approved $125 million in development funding for nuclear thermal propulsion rockets, which speeds up the development of nuclear-powered rockets. In May 2022, DARPA issued a proposal for the next phase of their demonstration rocket for Agile Cislunar Operations, also known as DRACO Nuclear Thermal Engine Program. So in 2021, initial engine designed by General Atomics and 2 spacecraft concepts from Blue Origin and Lockheed Martin were selected. And as of latest, NASA and DARPA will test their new nuclear engine for their future Mars mission. This will help us to reach Mars much faster compared to traditional rockets. The project is intended to develop a pioneering propulsion system for space travel far different from the chemical systems prevalent since the modern era of rocketry dawned almost a century ago. The 2 agencies will work on a nuclear thermal propulsion system, as NASA wants to use this propulsion technology to send humans to Mars in the late 2030s. Using a nuclear thermal rocket allows for faster transit time, reducing risk for astronauts, NASA said in a press release. Using current technology, NASA says, the 300 million-mile journey to Mars would take about 7 months. But with nuclear thermal propulsion, getting to Mars could take as little as 2 months. NASA is also testing its new portable nuclear reactors to power the crew flight systems and also use its sustainable power source for its lunar and Mars manned program. These small reactors will also be used to power their lunar and Mars bases, for astronauts to live, grow food, and work on the Moon and Mars, to colonize Mars in the future and use it as a launch pad for further interstellar travel. So, the days of living on Mars or traveling across the solar system in days are much closer than a sci-fi fantasy.